So today we are going to discuss something kind of a very fundamental, but most of software engineers doesn't know this part. Okay, so because most of them starting either from Spring Boot, either from like Nest.js or a Node Express, some sort of a high level where they have no idea how this ground level works. Okay, so today we are going to lay down that one. So when we start microservices and all other things, that will be helpful when we go there, but we need to know this before we go there. Now if you take, I'll again this also take as an example with Java. If you take, when we write a Java program, right, let's say application.java, right, how we compile this? Java C, right, Java C application.java, right. So then what it produce? What it produce? Application.class, right, and then we run this on a JVM. So we don't run this on a JVM. We call java.application. So then it will create a JVM, and like Java will create a JVM and put this one on that, and then it start to execute, right, and we discuss all of that. So now think like this, right. So now she is writing this program on her laptop, right. So she is writing this program. Okay. So now she is in another laptop, right. He is in other laptop. So they cannot run this program. Why? Because bytecode or a class file is in her machine, right. So she can write, she can execute this without any issue, but they cannot. Why? Bytecode is there, right. When you run the program, JVM create, we learn JVM is a process to the operating system, right. So that process being created on this machine. There is no way you can execute, you can use this program from your machine unless you copy this class files to your machine and install JRE. Okay. So this was okay for some time, like 20 years ago, 25 years ago, this was okay, right. Let's say you get the hardware store or something, right, you have a machine, you run inventory system on that, it's cool, it's okay, because those days kind of a transferring from books to system, right. So having a system is a big thing, right. So now like people used to say, okay, we need to put into the system and the system is there, so it's a very closed environment, it's cool, it's okay. But now when the business involved, sometimes they may have multiple story buildings, right, and or maybe they have other branch somewhere. So now you copy this system everywhere, now there is no link, right, you understand. So now let us say these are different stores or different floors on the same building. So now we have a stock 100 on everywhere. So this machine saw like 10, but still they says 100. Why? They have independent stock, right. So now we needed to have a something where we can connect and run the same system, so then we can get a benefit of a system. So this is kind of a when the business evolved, right. Early days this is okay. So now we needed to have something where you execute remotely. You put a system on one machine, the others can execute or use that system, right. So when we do that, now the problem is, so we have a JVM here, if it's considered as Java machine, Java. So now they cannot do because they don't have the JVM. So what we came up with something like this, right. something like this. How about this? We run like, now this is her machine, so this is her machine and this is your machine, and like in our example. So now what she do is, she write a program. What that program does is, right, it has a multiple other sub programs, right. She has a multiple class files, right. It has multiple class files, 3 class files. Probably this is for adding, this is for subtraction, this is for multiplication, right. So now what this program does is, this listen to outside, right, this listen to outside, and then what they can do is, hey, I want to add 2 numbers. They talk to this wherever listening port and give the number, right. So now this program will use this one, load this class and do the whatever the operation and return the results. Okay. So there was a the different names calling, but the one is RMI, remote method invocation, right. So we are calling method which is not local, which is on the remote. Okay. So keep in mind, yesterday also we discussed in the evening, here like the problem with the software engineering, same word, the based on the context you are using, it has a different meaning. Okay. So I am trying to build a story. So sometime technically maybe this is not exactly correct. So if you go and search what is RMI, so you have a very different explanation to RMI, how that works and everything, right. But I am trying to build a story, so where you understand from A to Z how this evolved and how it worked. Okay. So this may not be exactly fitting. So now what we do, we like she write this program, now 4 programs are running. Okay. So this program is running, this is exporting a port, and then like she can send the number. So this load this class and return the results, right. So now he send the, okay, give me I need this number to subtract, right. So now come into that port and then load this class and do the operation and return the results. Things are good. Now what we did, we expose our program to outside, right. We expose our program to outside so others people can connect. Okay. So now who is doing the operations? These 3 classes. But this act as a, so this one act as a container to all other programs, right. That acts as a container to all other programs. Understand? This is act as a container. So now these primarily RMI was not really good, and then HTTP 1.0 came, right. HTTP 1.0 came, then 1.1 came, right. So then this keep evolving. So we wanted to have a listen something over the HTTP, right. So parallelly there was HTTP, when the HTTP release, right. So people start to build website, especially web 1.2. So where you deal with the static contents. The static contents mean the content don't change. After you build, the content stay forever. For example, company web portal, portfolio website, those contents are not changing dynamically. You go, no matter who goes, from where goes, what time of the day you go, it's the same content. Okay. So for that, for website, we needed to have something called web server, right? Web server. What the web server can do is dealing with the static content. Right? Dealing with the static content. Ideally HTML, CSS, JavaScript, and so and so. Okay? So we are dealing with the static content. So now this was okay. People using website, building website, company has a website, right? This is cool, Web 1.2. And then when these involve, so these are not static. The number you passing is different time to time, so the result is different. So you cannot deal with the static web content. So now we have a container, right? She wrote a separate program where that program can run other Java program, load other Java classes and execute and give the results. Why? So now it's avoid these Java classes copying everywhere, right? So there's Java classes copying everywhere. So now what she does is she load this program and run it and give the results. So what they have done is they took this concept and built something called web container. Right? Build something called web container. What the web container does is, not like a static content, it can host some program, dynamic, to produce a dynamic content. Okay? So Java came up with the concept called JSP and Servlet. Right? JSP and Servlets. So what this Servlet does is same thing. You can write a code in a way that execute on other JVM. Okay? Servlet doesn't create own JVM. Servlet need a container to run. It's the same concept. Right? Servlet has a life cycle, servlets load, destroy and so and so. So do get, do post. There's a separate story. I'm not going to teach you servlets, but just understand servlet is this. You run some sort of a Java program on a different container. Right? So now this servlet running on where? Running on where? Server. Right? So now client there has to be a client who can talk to servlets. Because this website is what can do. They are producing static content. They cannot talk to servlets. So you needed a front end to talk to servlets. So they are the where JSP came, Java Server Pages. Right? So Java Server Pages is combined with the HTML. So you can write a small standard HTML page, right? Standard HTML page, and inside that you can use a JSP tags. JSP tags mean JSP simply knows how to talk to servlets. That's it. Right? If someone is here who only can speak Sinhala, there has to be someone who can talk to Sinhala. If there is someone who can speak only English, there has to be someone only English. It's the same concept. So it's a client, kind of a client. So now, Java came up with something called JSP servlet. So now we start to call this as a servlet containers. Web container has other name called servlet container. Right, now we clear. So we have a web server for the static content and we have a web container or a serverless container to run servlets. Right. So if you get Apache or Nginx, these are examples for web servers. Right. So if you get Tomcat, right, and Jetty, those are examples for servlet containers. Okay. So this serverless container, so if someone asks what is a serverless container support Java servlet specification. Right. So maybe you have learned something called like Java has a Java ME, SC and EE or something like that. So that was like previous categorization, standard edition, enterprise edition, mobile edition. We don't follow this anymore. So now, what the web container does is, or a servlet container does is, it supports Java servlet specification. Right? Java servlet specification. Now we are happy with it. Right? So now we are okay. How the servlet container works? From the back end, there is a servlet, right? And the front end, there is a JSP. JSP can talk to servlets. And the servlet, this container can manage the life cycle of the servlet. It can load the servlet, it can serve from servlet, it can destroy the servlets, and it do everything. This is exposed through the HTTP. Okay? So now, when business from single layer, single computer business. So now we can have a multiple floors or a multiple warehouse. Now we can link and we can run a system. Now when these requirements evolve, we wanted to have kind of a complex requirement. For example, let's say I go to ATM, right? So when I go to ATM, I want to transfer some funds for him. So now what happened? I said, okay, 5,000 rupees transfer to his account. So now 5,000 deducted from my account. When it tries to insert to his account, there was some failure, right? So now the 5,000 is nowhere. It is not in my account or not. It's not his account. I tell, okay, I transferred because it is deducted from my account. He said, no, I didn't receive it because it didn't credit to his account. Right? So we need to do something called transaction handling to do something like that. And with notification, send the messaging, because HTTP is kind of HTTP is a synchronous protocol. So it kind of introduced its own slowness. So we need something of messaging. So this type of a complex requirement Servlet cannot handle. Can, but you need to run a tons of boilerplate codes, same codes everywhere, right? It's not easy to do with the Servlet. It's not impossible to do. It's possible to do, like database connection, transaction management, messaging, right? Session handling, those type of things can do, but it's a very complicated to do. So many boilerplate code to run. So now Java EE or Enterprise Edition came up with the concept where you can run these as a separate objects, separate services per se, right? Component, you can say component. So for that we needed to have something called application server. What the application server does is, it is higher than this, which can run full-fledged business components. It can do transaction handling, it can do messaging, right? Like for example, it supports something like a JMS, Java Messaging System, right? So JPA, Java Persistence API. For example, usually with the server, other programs, what we do is we use a JDBC to connect to database. It's a JDBC connection. So you need to write a CRUD operation, create, update, delete, all those things you need to run as a plain SQL, plain SQL command. But JPA came, Java Persistence API, right? And then that inherit from the Hibernate created out of this, right? Hibernate created from the JPA. Okay, Java Persistence API is kind of a specification, but it also has its own implementation. But Hibernate came out of that. Then Hibernate was so popular. Hibernate is a ORM, Object Relational Mapping. So you don't write SQL queries anymore. You create your employee class and you say employee.save, it go and save to the database. You don't have to say insert into employee, TBL employee values. You don't have to do that. So now, important thing is, there's something called EJB, right? EJB. Now don't write EJB, right? EJB, Enterprise Java Beans. EJB network came. So there was a period came, we don't need any web application if you don't have EJBs, because EJB was so kind of a hype, right? So you know that sometime these days, what is the hype? AI. When you go to a new client, they are asking, can you do something AI? Why? They don't know why they need AI. They don't know what they can do with AI, right? So, but they need something AI, so they can go and say, we are using AI, right? So what usually we do is, we use some sort of a chatbot or something and show and this, okay, so now you have AI enabled, right? So then we can publish in the website, so we are AI enabled, because end of the day we send in that query to ChatGPT or some sort of a model behind the scene. So before that, microservices, right? Customers doesn't know what they need, they say we need a microservice project. Likewise, they needed to have some sort of EJB projects. We need to have a big component to run on our servers and so and so. So the application server. The famous one was JBoss, which is later on renamed. right? Oracle has different application servers, and application server is the kind of the highest on this rank. Keep in mind, application server can run servlets, but servlet container cannot run applications. That's a difference, right? That's a difference. So, like for example, if you have a like 10-wheel this truck, right? You can put a bread on that and you can transport it. It's not a problem. It's not impossible to do, but useless. And you don't need a 10-wheel to transport a bread, right? You can go in a food cycle, but you cannot transfer container on a food cycle. It doesn't work like that. So that is how it goes, right? You can do it. You can even run your static content on these servers. It's working, but you shouldn't do it, and we don't have to do it. So now, this is one of most wrong answer we get in interviews when we ask what is the difference between web server, web containers and application server. Very simple answer. Web server is something, web server is a server which serve for a static content. Web container, also known as servlet container, which support for Java servlet specification. Application server is a server which support full Java EE spectrum. So that is a definition for these things. So J was later on renamed as a Wildfly. And there's other WebLogic. WebLogic also famous application server. So now you can think this something like this. Let's say let's say you want to have a dinner or a lunch. Let's say you want to have today lunch. You have two options. You can go to some like small hotel outside. You can have your lunch, or you can go somewhere like a Cinnamon Grand or a Transasia or someone. You can have your lunch, right? So no matter where you go, at the end of the day, what you get is your lunch. But when you go for the higher the hotel, you have more features. Probably you can use a swimming pool, right? They have a swimming pool. They may have music clubs. They may have a karaoke. So they may have some pool games, something like that. So, but you're going for the lunch. But if you want to kind of do something with that, so you have infrastructure supporting it, right? But you cannot go to here, this hotel, and asking, okay, can we have a pool table, right? They don't have it. So it's like that. So this is doing the same thing, but it has a very rich features, right? So now the problem was this. The problem was this. So this era, if you are a engineer with who knows EJBs and all those Java EE spectrum, you are a very high paid, because this is damn hard. Understand Java EE and write the code of Java EE is very hard. Okay? So this is the period where we use SOAP. SOAP is a messaging protocol, the protocol to write web services. Writing SOAP services is not easy. Right now you just need like a 1 minute to host just a simple REST API. It's a very quick. You do it and you run it, it works. But writing a SOAP API is not like that. You need to create skeletons, and from you need to write a WSDLs, web service definition language, you need to define it, and because it's a very different thing, right? So SOAP is a protocol where what is different between a protocol and architecture. So if it is a protocol, it's come with a bunch of rules which you cannot violate, because that is how it works. That's it. Architecture is something you can customize if you want. For example, let's say you want to build a house, right? You go to an architect and you get a plan. They give you a blueprint. Okay, this is how your house looks like, right? They said, okay, this is the width and this is the height and these are the walls and these are the rooms, these are the windows and so and so. Now what typically happens is when you build the house, you keep visiting, you feel like I need a window here also, right? And sometimes you remove a window, you add new door or something like that. So what you do is you customize in the architecture, right? But probably, so probably architect didn't put a window on this wall because he might need to take the weight of your roof. But you didn't know that, you just put a window. So now like 5 years later you see the cracks on the wall. Why? Because you customized it, right? So we can, architecture always can customize, but you need to take these repercussions. Rest is architecture. For example, typically GET requests don't have a body, but nothing is stopping you to send a body. If you send the body, it's accepted. But architecture says typically, generally you don't send a body. It's a guideline. Typically, if you want to write a record, you need to write a post call, post request. Okay, but you can send a post call and get the record. Nothing is stopping you to do it technically. Okay, so the SOAP came. Writing these APIs was super hard because writing this Java EE on the Java EE spec is hard. So then there was a framework called strut emerge, right? Struts. What the struts did was it hid this complexity under the hood. So strut was so popular. That was super popular. So now what happened was, so people who was writing those Java EE application, the APIs, they suddenly moved to the struts, right? So now when they are hiring Java engineers, struts is something must have. If you don't know the struts, you are not a Java engineer, right? Now strut was also like super hype, right? They realized, okay, so those days we didn't have a concept called going viral, right? So now strut actually went viral. So now they were super hype and they said, okay, we can do more better. They released a Struts 2.0, which is a completely different to the 1.2. Now people who paid for the courses and like learn the Struts 1.2 now outdated. They need to relearn it, because Struts also didn't know we will be this popular, so they changed it. So people lose the kind of a faith on the Struts. Okay, so this is not going to work. When the 3.0 comes, we need to learn again, right? We can't do it. No? So meantime, there was another project emerged called Spring. Right? Spring knew what Strut did wrong, right? So they came up with the core, Spring core. No matter what we do, this is how Spring works. We have a core. On top of that, we may build things, but fundamentals stay same, right? For example, in a normal program, we say Java class, right? And we call it as a Pojo. What does Pojo mean? Pojo mean plain old Java object. When something to become old, there has to be something new. What is the new? New is the beans, EJBs, right? Because in the Pojo you need to create a new keyword, right? So there are some DI framework came on, dependency injection framework. So now Spring start to refer these classes as beans, right? So now when you write a Spring Boot project, you go create a bean annotation. So that is what happened, right? That's where this born. So Spring came up with something called beans, right? So there are so many other concepts came. So Spring became so popular, right? On top of the Spring like a huge umbrella. Under that there are so many products. And out of that, Spring MVC was significant. Right? Spring MVC is significant. What is MVC? Model View Control Architecture. There is an architecture pattern to design web application, right? So what is it in the simplest way? Let's say you have a web page and you have a database or a database, and then you need to write some data to the database and read some data from the database and show on the web page. If you want to build this API, this application, so what is the web page is a view, right? You have the view, that's a web page, right? So we model the data. So that is the model is referred to your data structure, how you going to store it, right? And the controller is manipulate the data based on the view, right? We typically say view use controller to manipulate the model. That's MVC pattern. So now that's a typical example used to teach MVC. So I don't know whether you guys had the what's it called? Not the wallpaper. I don't remember. So like in a school we give like articles and you publish in like some sort of a notice board kind of a thing. I don't remember what it's called. So there are committee, like I don't know whether you guys did it, we did it, right? In every class, like you submit an article, so we pick like 3 articles from there, and like in the news, it's a news hub, you go and publish there. It's a good thing to publish your something you written or your art or your poem or something on a school wall is a big thing, right? So that is something like typical example to teach MVC. So now Spring MVC, what it does, it use Java EE complex architecture and it generate all the codes under the hood based on the simple code you write on the Spring, right? Based on the simple code you write on a Spring. So that is where Spring MVC. The MVC, if you create a Spring MVC project, you have the view also inside that, right? You can use JSP, FreeMarker, Velocity or anything as your front end pages, but it is not a single. So nowadays what we do is you use Angular or React to design the front end. That is just a front end. It doesn't have the back end, right? But if you write a ASP.NET or a Next.js, not the Next.js, Next.js application, that also have some sort of a server-side component, right? PHP also has things like a Laravel, so they can do it. You can have a separate template engines. So what the Spring MVC did the same thing. You have back-end codes and front-end codes and the model, everything inside the one package, right? Inside the one package. So now Spring MVC was super popular. Every web application was developed using Spring MVC. Keep in mind, web applications and websites are different. Website is what? Static content which run on a web server, right? Web application is what? Which has some sort of a server-side rendering, server-side coding, right? So now what we are transferring from so this JSP serverlets, right? So this EJB, the problem is this: Spring MVC did not support EJBs, right? What the Spring MVC did was JSP specification, servlet specification. So as a result, what you need to deploy a Spring MVC application? What you need to deploy Spring MVC application? Web server, web container or application server? Web container. Typically Tomcat. Use Tomcat. Right? You understand? Spring MVC does not cover EJB part. It is a servlet. But it was good enough to handle everything. Why? Because EJB came up with this JPA architecture. They introduced Hibernate, right? EJB persistence APIs, and then the creator of that one took it out and exposed as a separate library called Hibernate. So Spring used Hibernate to get that JPA features. So now, do you need EJBs? No, you don't need. It's decomposite and simplified. Right? Nowadays, unless this application was written in like decades ago, you don't find EJB based applications. We don't design these days because you don't need. Okay. So now Spring MVC came. Now this is a period like a 2013, 14. Right? Then Martin Fowler came up with a concept called microservices. So with that came up with an idea, you should not embed the back end with the front end. Right? You should have a back end team where they experts on writing back end APIs, where the front end teams, they can come up with a nice UIs, because requirement evolves. So now when this happen, what is the problem? If the UI change, you need to put entire build back. And there are some application we start deployment on Wednesday, we complete the deployment on Friday, right? Production deployment, right? Why? Because we switch in data centers, we deploy entire, because now we have to, you may change simple thing, right? For example, in 2008 I remember, there was one of institution wanted to change the date format. As a leading financial institution, they want to change the date format. The cost they charge, they have costed, they got the estimation for 6.7 million rupees to change the date format, right? So now outside people, to change the date format, even intern can do it. But the problem is changing the date format involving, you have butterfly effects, right? You have to change the variables, you have to go to the database and you see where it's integrated, all the integration APIs, other UIs, everything you need to check, right? So it's not practical, okay? It's practical, but it consumes more time. So, but business was emerging, so now you can't wait like weeks and weeks to get the results done. So we came up with the microservice architecture where we separate the back end to the front end. Why? Because MERN was so popular, right? MERN was so popular. What is this? Let's say first go with the mean. What is this? Mongo? Express? Node. This is not Angular. This is Angular JS. Angular was not there when the mean stack comes. Okay, Angular JS and Angular is two different things. Some people yet to think like, okay, Angular is Angular JS 2.0. No, Angular JS is a complete different library that we code in differently, right? And there was something called jQuery came. jQuery is something like no matter what you want, you can do with it, right? You can manipulate the DOM like insane. So this is a Web 2.0 by the way. But Web 1.0 is just having the static content, right? But when it comes to the Web 2, so we can update partial pages, right? We can update partial pages. So there the SPA was very popular. SPA is not the way you can go, single page application. That was super popular, right? SPA, single page application. What a single page application does is, best example is Angular. You have a single HTML page, right? So based on the responses or the URL, you replace the HTML body, right? So how we can have HTML page, right? You have HTML tag, and then you have a body tag, you have a header, title and all those things, but basically you have a body tag, right? And you have a body tag close and the HTML close. You have intermediate, head and title and everything. But now what the SPA, single page application does is, it replaces this based on the content we need to display. But for an entire project you only have one page. For Angular project you only have one index.html page, right? So now these are super popular, these concept. So we needed to have a separate back end to the front end. Sometimes things falling like in the same time, like, so Martin Fowler came up with the microservice idea, and then containerization was super popular, right? So virtualization or a VMware is kind of moving to the Docker side. everything happened on almost near period, right? So now mean stack was popular, and then it lead to get the front end separate, right? So then Angular JS came, right? And then Microsoft came up with the saying, okay, I think we need to build something. Angular JS is getting super hype. We need to do some influence. So they came up with a TypeScript and then merge it. Then we got the Angular, right? Angular is a very rich one. So if you are not learned any front end yet, start with Angular. Don't start with the React. Okay, this is very arguable. Why I personally say so. React is a library. Okay, you can do some rich things with the React, but React is a library. Angular is a whole framework. If you learn Angular, it is super easy to catch the React. But otherwise, not that much easy. Okay, if you learn Angular, React, come up with go to Angular. It's not that much easy. It's not impossible, but it's easy to go from other side. So now Spring gave something called Spring Boot, right? Where you are superstars, right? You guys most of started the Spring Boot. See how long journey it came, right? The Spring Boot, here's a different. If you have a Spring application, right, what you need to do, okay, here those days how we deploy, okay, so we have we don't use NetBeans, something like Eclipse or some sort of IDE, we write the code, right, and we compile. Let's say you change something, some variable value or something changed, small text, maybe label value or something you change, we compile and it takes some time. It produces a WAR file, and then you go to Tomcat, you stop the Tomcat, you copy this file to the Tomcat, and you start the Tomcat and see whether it's working. If it is not working, come back, do the same thing, right? Then ant came, right? Not the ant, right? What the ant did was, we were able to automate that part. When you do and run, it compile our code, create the WAR file, and push into the stop the container, kind of same thing but automated. So now anyway, what you need? You need a container to run this program. You need a container. Okay. So what the Spring Boot did, it made it containerless. But it's like a serverless. When you say serverless, its meaning is there is no server. But in practical, can you run anything without a server? No, you cannot. What it means, we don't handle the server, but server is there. Containerless means they embed the container into the framework. That is why when you run a Spring Boot project, you don't download the Tomcat. You don't download the Tomcat and configure. And I have slides I will share. So it tells you step by step how you can configure the Spring MVC, where you need to download the Tomcat and you need to create a project and then link that all those. But in Spring Boot you don't have to do it. Why? Because container is embedded. So now people were going with the Spring Boot and Angular. Spring Boot and Angular. Okay. So but keep in mind, Spring Boot may be super hot, maybe it's so popular, maybe superstar, but it came all the way from here. But still, a Spring Boot cannot produce EJBs. But what it does is, so what, okay, let's two things, EJB, so Java EE provide, right, or application server provide. One is a JPA, Java Persistence API, and JTEI for transaction, JMS for messaging, those type of thing, right. For the JMS, so the messaging system, you can use Kafka or RabbitMQ or anything based on your requirement. And for the JPA, you have a Spring Data JPA. What they have done, whatever the things they had, they took it to under the Spring. For example, with the W specification, they heavily enforce into the security, right? They heavily forcing to the security. But with the Spring, what they have done is they push it to Spring security. Okay, give me 1 second. So now this is the kind of from very beginning running on an application on your client machine and come up all the way up to the beginning of the microservice. We are in the horizon, we just see the microservices, but we didn't jump into that. Okay, so it can be microservices, can be not a microservices. We are going to discuss like everything not required to be microservices. We are going to discuss that. So, however, so this is the where the web APIs, this is a landscape of web APIs, no matter what, right? It can be a REST API, it can be some sort of a next type of a with the serverless side component. But what you need to understand is whatever the EJB packed into that, now we have a separately loosely coupled, so you can use whenever you want. You have options also. For messaging, you can use a Kafka, you can use a RabbitMQ, you can use ActiveMQ. Those are not same, but can use based on your requirement. Okay. So now why I did this, why I spent today to discuss this, because I really want you guys to understand what we do and why we do. Okay, not just jump into Nest.js or a Spring Boot and write a API, but under the hood you need to understand how these internal structures work, right? I'm not sure if I have time, before I go into Spring Boot or some sort of a web API, I'm going to teach you the Spring core, what exactly bean mean, and how the bean, what are the bean naming conventions, and what are the DIs, what are the DI strategies, and so and so. Okay, good. That's it for the day. I need to close it early today, and not early, we cover 1 hour.